Hello everyone. In this module, we can discuss the concept of Shannon Fano coding procedure with an example. In this example, a discrete memoryless source has 5 symbols, namely x1, x2, x3, x4 and x5. And the respective probabilities are p1 which is 0.4, p2 which is 0.19, p3 which is 0.16, p4 is given as 0.14 and p5 is given as 0.11. So if you take the sum of all the even probabilities, it will be equal to 1. So here in the question they asked you to construct the Shannon-Fano coding procedure for this source. Also calculate the average code word length followed by coding efficiency. And here the partitioning value m is given as 2 bits per letter. You can also extend the same for partitioning value of 3. If the partitioning value is 2, we can consider the encode bits as 0 and 1. If it is 3, we can consider the bits as -1, 0 and 1. So coming to the process of Shannon-Fano coding procedure, in the step 1, first we will list all the source symbols or messages in the order of non-increasing probabilities. So here if you observe all the probabilities, these are all available with the non-increasing order probabilities. The question itself, they are given in the decreasing order. So there is no need to rearrange all the probabilities. In the step 2, we can partition the symbols or messages into 2 most equiprobable or approximately equiprobable subsets and assign 0 to the upper set and 1 to the lower set. And in the step 3, let us continue this process, each time partitioning the steps with really equal probabilities or approximately equiprobable subsets. So the process of partitioning will continue till each subset consists of only one message. So let us go through the representation table. In this, the first column is symbols. Here just we have represented all the symbols with the probabilities of decreasing order, or you can say non-increasing order. So if you see all the probabilities, we have represented in the decreasing order. So coming to the partitioning value, here m is given as 2. So you can partition this whole set into 2 subsets having equiprobable or approximately equiprobable state. So here if you sum up the probabilities of x1 and x2, it is 0.59. And if you sum up all the remaining 3, it is 0.41. So here you can partition the set into 2 subsets in such a way that it is having approximately equiprobable subsets and assign 0 to the upper subset. And what is assigned to the lower subset. Again, in the second partitioning, again we will partition the upper subset into 2 subsets, such a way that upper subset consists of 0.4 and lower subset consists of 0.19. Here there is no possibility of approximately equiprobable. So here nearly equiprobable case we have taken, and you can assign 0 to the upper subset and 1 to the lower subset. Similarly, you can partition the lower subset, first lower subset in the partition 1 again into 2 subsets consisting of 0.16 in the one subset and 0.14 and 0.11 in the lower subset. So you can assign 0 and 1 to the lower subset. So here if you see the x1 probability, there is no possibility to partition here because the first subset consists of only one element. Similarly here also the subset consists of only one element. Here also only one element. But if you see the lower subset, it has 2 elements. So again there is a possibility of partitioning into 2 subsets and assign 0 to the upper subset and 1 to the lower subset. Now after representing all the codes to the respective symbols and check that there is no way of partitioning here. So next step is to represent the code word. So if you see the symbol x1 here, you can represent it as 0 and 0. The code word is 0, 0. And coming to the x2 code word 0 and 1 that we have represented. x3 1 0, x4 1 1 0, x5 is 1 1 1. That's what we have represented. Next step is represent the code word length. So here code word is 0, 0. So if the length is the number of bits available in the code word. So 2. The bit may be 0 or 1, but we have to represent the length. So here for x2 the length is 2. x3 also length is 2. x4 it is 3. x5 it is again 3. So after calculating the code word length for each symbol, here you have calculated the code word lengths for all symbols. Then in order to calculate the average code word length, just you have to multiply the probability with code word length. Like that you have to multiply the probability, the respective probability with the respective code word length. So 0.14 multiplied by 0.3. So average length can be attained by taking the summation of products of the probability of symbol and code word length. So here that's what we have written. So L is equal to summation K is equal to 1 to 5 because here we have 5 symbols. Probability multiplied by the length of symbol. So that's why we have written 0.4 into 2 plus 0.19 into 2. Like that we have evaluated and we obtained the average length as 2.25 letters per symbol. Next step is to calculate the entropy. H is equal to summation K is equal to 1 to 5 probability into log 1 by probability base 2. This is the expression for entropy and let us take the first, let us substitute the values for each and every symbol. For the first, if you see the table, for the first symbol, the probability is 0.4. Second symbol, the probability is 0.19. Let us substitute the values here. So 0.4 log 1 by 0.4 base 2 plus 0.19 log 1 by 0.19 base 2 plus 0.16 log 1 by 0.16 base 2. Like that, so on. Fifth symbol probability is 0.11 log 1 by 0.11 base 2. If you evaluate this whole thing, we have obtained the entropy value as 2.15 bits per symbol. But the expression for code efficiency is h of x by average length L bar into log m base 2, where m is the partitioning value. In our example, we have partitioned the each set into 2 subsets. So m is 2. So if you take log 2 base 2, it will be 1. So directly h of x by average length, that is entropy is 2.15 by our average length is 2.25. So we obtained efficiency as 95.5%. In the same manner, you can proceed with different examples. In the second example, you can see the message probabilities. Here we have given 8 messages with respect to probabilities. So we will partition this into 2 subsets. And again, you have to assign 0 to the upper subset and to the lower subset. Like that, the process of partitioning will continue till each subset consists of one element. Then we will calculate the code word, then individual length, then average length, followed by entropy, and then finally we will evaluate the efficiency for efficiency of the particular application by using Shannon Fano coding procedure. The next module we can discuss the Huffman coding procedure. Thank you for listening.